Hey everyone, and welcome back to the channel. Today, we're pulling back the curtain on something that makes all the incredible AI tools we see every day possible. We're talking about the digital engine, the hidden powerhouse, AI infrastructure, and cloud computing. We hear about ChatGPT, Midjourney, and self-driving cars, but what's really happening behind the scenes? What's the secret sauce that lets these models learn, reason, and create? Stick around, because we're about to explore the massive, complex world that forms the true backbone of artificial intelligence. Let's start with the hardware, the raw muscle. You've probably heard of CPUs, the brains of our regular computers, but for AI, they're just not enough. The real stars of the show are GPUs, or graphics processing units. Originally designed for gaming, their ability to perform many calculations at once, what we call parallel processing, is perfect for training AI models. Companies like Nvidia have become giants by specializing in these powerful chips, but the innovation doesn't stop there. Google went a step further and created TPUs, or tensor processing units. These are custom-built chips designed specifically for their own AI framework, TensorFlow. They are hyper-specialized, making them incredibly efficient for specific machine learning tasks. Now, imagine not just one or two of these, but thousands of them, all linked together in what we call high-performance compute clusters. These are the supercomputers of our time, warehouses filled with racks upon racks of processors, all working in unison to solve some of the most complex problems in AI. It has this sheer computational power that allows us to train the massive models that are changing our world. So you have the power, but where do you put it? That's where the cloud comes in. It's not practical for most companies, let alone individuals, to build and maintain their own AI supercomputers. This is where cloud giants like Amazon Web Services, Microsoft Azure, and Google Cloud Platform step in. They offer something called infrastructure as a service. Essentially, they give you access to all that powerful hardware on demand. You can rent as much computing power as you need, for as long as you need it, without the headache of buying and managing physical servers. This scalability is a game changer. An AI startup can go from a small experiment to a global service overnight, simply by scaling up their resources in the cloud. These platforms also offer specialized AI and machine learning services, making it easier than ever for developers to build and deploy sophisticated AI applications. Of course, AI is nothing without data. We're talking about enormous datasets, sometimes petabytes in size. A petabyte is 1,000,000 gigabytes, just to give you an idea of the scale. Training a large language model like feeding a giant digital brain, and it needs to be fed quickly and efficiently. This is where high-speed storage and data pipelines become critical. We use technologies like NVMe SSDs for lightning-fast data access and build sophisticated data pipelines that clean, process, and stream data directly to the training clusters. Think of it as a super-fast, automated conveyor belt, constantly supplying the AI models with the fuel they need to learn. Without this efficient data management, even the most powerful hardware would just be sitting idle, waiting for information. Now, let's connect everything together. Having thousands of processors and massive storage is great, but they need to talk to each other, and they need to do it fast, really fast. We're talking about incredibly low latency networking. In a training cluster, if communication between GPUs is slow, it creates a bottleneck that slows down the entire process. That's why we use specialized interconnects like NVIDIA NVLink or InfiniBand, which allow these components to share data at breathtaking speeds. On a global scale, these data centers are connected by a web of undersea fiber optic cables, allowing a user in Tokyo to access an AI service hosted in a data center in Virginia with almost no perceptible delay. This global architecture is what makes AI a truly worldwide phenomenon. So we have the hardware, the data, and the network. How do we manage it all? This is where the software stack comes in. At the base layer, We have orchestration tools, and the king of orchestration is Kubernetes. Originally developed by Google, Kubernetes is like the ultimate project manager for our AI infrastructure. It automates the deployment, scaling, and management of applications across our clusters of computers. It makes sure every resource is being used efficiently and can even automatically recover from failures. On top of Kubernetes, we run the AI frameworks themselves. The two most popular ones are TensorFlow, which we mentioned earlier, and PyTorch, developed by Meta's AI Research Lab. These frameworks provide developers with the building blocks and tools they need to design, train, and deploy machine learning models without having to write everything from scratch. They handle the complex math and optimizations, allowing researchers and engineers to focus on creating innovative AI architectures. This layered software stack, from the orchestrator to the framework, is what makes the immense complexity of AI infrastructure manageable and accessible. So, what does the future hold? It's incredibly exciting. One of the biggest trends is edge computing. Instead of sending all data to a centralized cloud for processing, we're starting to run AI models directly on devices like your smartphone, a smart camera, or a car. This reduces latency, improves privacy, and allows for real-time decision-making, which is crucial for applications like autonomous driving. Another critical area is sustainable AI. Training these huge models consumes a massive amount of energy. The industry is actively working on more energy-efficient hardware and developing green data centers powered by renewable energy. We're also seeing research into more efficient training methods that require less computational power to achieve the same results. And then there's the truly mind-bending stuff, quantum integration. While still in its early days, quantum computing has the potential to solve problems that are currently impossible for even the most powerful supercomputers. Integrating quantum processors into our AI infrastructure could unlock new frontiers in drug discovery, materials science, and fundamental AI research. The synergy between quantum and AI is one of the most exciting long-term prospects in technology. To wrap it all up, the AI revolution we're witnessing is built on a phenomenal foundation of infrastructure. It's a symphony of specialized hardware like GPUs and TPUs, the limitless scalability of the cloud, lightning-fast data management and networking, and a sophisticated software stack that ties it all together. This invisible backbone is constantly evolving, pushing the boundaries of what is possible and paving the way for future innovations we can only begin to imagine. The future of AI is not just about smarter algorithms. It's about building a smarter, more powerful, and more efficient world to run them on, all powered by the cloud. Thanks so much for watching. If you found this deep dive interesting, don't forget to hit that like button, subscribe for more content on AI and technology, and let me know in the comments what part of AI infrastructure you'd like to learn more about next. See you in the next one.